ये कौन से प्लेटफॉर्म पे आप देख रहे हैं? MST.
Yes, sir. We can proceed now, sir.
Okay, so thank you. Welcome back
Thank you.
to the session. So now I'm talking about some topics related to application base, related to the resilience for the autonomous vehicles and also cyber-intrusions. So for today, I'm mainly focusing on the autonomous driving scenarios and some complexity we have from the cybersecurity. So for that's it. The lecture today now is based on some trends and requirement analysis. So some research and development ideas and the goals, and what is the key research and development content, and some policy suggestion. So therefore, if we look at for instance, in the many countries in the world, specifically mainland China, that is the number one in automotive production country. And now they based on the policy of the country, so they are also the number one, they are selling the market. So by the 2025, there is a rapid growth of the car ownership is expected to reach to 300 million vehicles. It means that the number, for example, 310 vehicles per 1,000 people. This is basically the target up to now in China. So now you see that for this a huge number of the cars. So we have some issues about some accidents. So you see that the accident, so you see the percentage accidents for different items, and over the basically the traffic congestion. So the number of cars continue to increase the traffic congestion, the quality of the traffic and travel efficiency to complete decline. So the time wasting in the congestion, traveling time cannot be covered. Without some drawbacks, we have the increase of the number of the cars on the road. And also from basically from the accidents, you see that the half of the China annual GDP growth is lost due to accident. But now you see that even for India, I think for India, the situation also could be similar for the large number of population, the large number of the cars. So the accident and also traffic congestion could be also the one challenge. In many countries, especially the big countries like India, so this could be the similar problem. So now the ICV, so for the connected, the intelligence connected vehicles, so they have done some development in this context. So now, if we look at the vehicles, car vehicles, there is a two main keywords. One is about intelligence and also the connected. So the intelligence means that by adding the many sensors on the cars, so basically for the different sensor coverage. So you see that this kind of the sensors, so they can enhance the smartness of the car. At the same time, if we look at some topic like the connected cars, it means that for this a large number of the cars, if they could communicate either the two cars, a car between the two different cars, or even they can do some communication to some infrastructures, to environment. So it says that in the context of intelligent connected cars are rapidly evolving from the single vehicle intelligence to the system level intelligence. So now, if in India, if we want to implement the sort of the connected cars in the context of the intelligence, so we need to look at it from the system level intelligence. It means that integration of the roadside perception and the coordinated control. So this kind of the roadside perception is an environment basic to the information. It could be the some sort of the traffic light or other issues, and coordinated control. So supported by the road to vehicle information exchange and also cloud technology. These are some addressing issues of the limited perception and big decision-making capability. So now, because in Italy, we have a very advanced laboratory for the autonomous cars. So what we are doing, we are also doing a test of this kind of information exchange between the road vehicle, and also we are also looking at the cloud. The cloud technology, what does it mean? So what we are doing, because the data from the cars can be sent to the cloud. So now the integration of the cloud and also the driver and also the vehicle. It means that the cloud-based driver and the vehicle, and they can be integrated to the whole at the system level. And of course, if you have some information from from environment, this also can be augmented with this information. So now the system has a lot of data, and this data should be basically used for the decision-making capabilities, for enhancing of the witness of or the limited of the perception. And this means that for autonomous driving, enhancing basically the perception and also coordinated control is a key main challenge. Okay, so for this scenario, so if we come to the vehicle become more intelligent and connected, so they are developing into the computer on four wheels, giving rise to the cybersecurity issue. Okay, so because of this component like the wheels, and also this can be augmented with the whole all the system level, the cybersecurity issues exist in vehicle intelligence and connectivity. So in vehicle networks, so because of the many sensor and many data circulation, the complexity in the vehicle architecture is 100 new lines of the code. 70 to the 100 ECUs are gradually moving to the Ethernet architecture. So these a huge number of the hardware and also the software integration, they can bring a lot of threats to basically from the cybersecurity. So the charging information exchange. So enhance the charging information integration. For example, over 1 million charging points. So for example, this is the information for China, and over 200 interaction data points per charging sessions. So in the whole charging sessions, and basically the information of the car, such as the battery information, battery status, state of charging, all this information can be collected over the cloud, and that's it. So this is another issues we have in the cybersecurity. About the remote service function, so the driver's remote service function, so it means that the multi-level remote monitoring. So this is basically they build another challenge. So in fact, the in-network and also coming to the some infrastructure from the connected, so they can also bring some issues about the cybersecurity. So if we look at the normal operation of a smart vehicle hardware, software, with data system through technical and the management, measuring, securing, confidentiality, integrity, and also availability. So this is the ISO 21431. This is about the data, also security. So this means that how to integrate it to the system, we can follow this ISO. So the cybersecurity is the upper layer of the functional safety, and that's it is very important. And it means that if we look at the feature of the automotive cybersecurity in terms of the high availability, high vulnerability, and also the high value though, so it means that how to look at the susceptible to the unauthorized access, so treatments the functional safety and also privacy leakage. So in fact, for the automotive safety, the cybersecurity is the failure causes based on the human attacks, some maliciousness, and also the risk assessment, and these are sometimes are unknown. But important if you look at the functional safety, it means that What is the failure causes? Is it random, stochastic, or the hardware failures? So in total, the cybersecurity is the upper layer of the function safety. But if we look at the automotive cybersecurity threat analysis, for intelligent connected vehicle, ICV, so in the Internet of Vehicle, it means that in the IoV, so ICV and in the IoV environment face a wide attack surface and many cybersecurity risks involving the automotive, communication, and the computing fields. So for your information, there are 4 layers of threats from the cloud threats, transmission threats, endpoint threats, and external threats. These are the some threats basically based on the 4 layers we have for the connected cars. So but you know that the reason I choose ICV because I have no idea about the ICV in India because more or less we did a lot of research on ICV in Italy, also with some research in China, and that's it. I'm familiar with these 2 parts. But coming back to India, so I'm not sure how is the status of the intelligent connected cars in India. I have no information. But in fact, how we can look at the threats and attack, including the security threats to the mobile intelligent terminals, ICV security threats. And you see that for ICV, so you can look at, for example, the T-box, the CAN bus, ECU chips, and a lot of updates. So if you look at this in the car, so in the IoV, Internet of Vehicle environment, each intelligent connected vehicle has on nearly 200 electronic devices. So it means that the power systems, the T-box for the gateway for the connection, intelligentization about the different operating systems, about the sharing the data from the Bluetooth or other mechanism. So this integration of the electronic component and the different interface, internal, external, wired, wireless, so they are under the exposure of the attack surface, and they can create the risk in the cybersecurity risk. So now you can see that the intelligent cars, especially ICV, connected cars. So the cybersecurity is a big challenge, and that's it. I can tell you that nowadays it's a very hot topic, and if you are interested, we can discuss with more details. So from 2015, so the BMW, they proposed the connected drive law and about the data leakage. So you see that 2016, about the remote setup, about the 2017, about the Tesla remote control. So and also the 2018, the BMW remote hack, it means that these authors says some focus on automotive cybersecurity. So it means that this number of the automotive cybersecurity incident, so from 2010 to 2019 has increased, especially in the last, after 2016, you see 7 times the number of the attacks that the problem has been increased. And it says that the number of the automotive cybersecurity incident has grown by 600%. And it means that this is a very, very serious challenge. So for this reason, there is a lot of issues how to enhance automotive safety performance. So just to handle this issue. But if we look at some sort of the global automotive cybersecurity initiatives, so 2008, the EU launched and also about these some standards. So if we come to 2013, the Japan introduced automotive cybersecurity guidelines. So, and then if we look at for example, 2016, some standard like SAE J3061, the US also released the first global cybersecurity guideline, 2016. So then it comes 2017, China. So they launched a cybersecurity law for the data protection. At the same time, the EU also worked on the cybersecurity principle for connected cars. It means the EU started in 2017. So 2018, again, the EU worked on the GDPR for the privacy, the right from the personal data. And at the same time, in 2017, also China worked on the Internet of Vehicle, IoV, for cybersecurity. So 2020, so you see that the ISO SAE, so and also China also again they work basically on the cybersecurity requirement for in-vehicle, EU remove. So now you see that this progress shows that how the different countries they have contributed to this kind of the cybersecurity initiative for automotive vehicles. So, but in fact, there is some other information maybe it could be interesting for you about some guidelines. So after releasing 2016, 2020, 2020, so you see that there are some releasing some guidelines. So there are, and all these guidelines is related to the automotive electronic system cybersecurity, or there are some but I'm not going through the details, but if you are interested, you can contact me, we can discuss. But in fact, so the first domestic guideline for automotive cybersecurity based on SAE, it was introduced. So, and then if it comes to the some sort of development approach and also the objectives. So automotive cybersecurity. So this could be as a dependent and also the emerging science. So this is a very basic for the emerging topic in the technology, but the automotive cybersecurity. So you need to closely accompany the deployment process of the connected, intelligent, and other emerging technologies. So you see that there is a very hot topic. There is a lot of complexity from AI, connection, sensoring, and also some technology, how to combine, how to integrate so this process. So it's a start from the basic theory, so focusing on the breakthrough in the key common technologies and system integration and also deployment technologies. How improve the construct of automotive cybersecurity technology platform, how we can do the demonstration side, and how promote the development. These are the some focus in this part. So about the sizing, the greater transformation of the deep integration of the global automotive industry and also the internet industry, because automotive industry about the ICV, so for the connected cars, plus IOV, about the Internet of the vehicles. So that's it. So these are should be the basic, we need to see how to integrate it. So the development objective, so it means that establish a comprehensive automotive cybersecurity system science and technology framework and fundamental foundational platform. So achieving the industrialization of automotive cybersecurity and also provide a solid guarantee for the rapid application and promotion of the connected, intelligent, and other emerging technologies. So you see that this is the basic objective, but this objective for any countries, so because these are the basic standards, so we need to follow this objective. But important is the complexity, the challenge. The cybersecurity is on the top of this ICV, IOV. The challenge is the cybersecurity, and that's it. How to deal with this cybersecurity is a very challenging topic. So in the automotive cybersecurity technical roadmap, so you need to look at some fundamental theories, some common technologies, system integration, deployment, how to develop a platform for demonstration, and also the next generation. But these are the some roadmap. At the same time, the cybersecurity for the onboard network, cybersecurity for the central cloud, cybersecurity for the surrounding ecosystem, and other cybersecurity for V2X communication process. So the positioning of the automotive cybersecurity technology integration, so with the life cycle and also the basic security technologies. So how to look at the threat analysis and the risk assessment and foundation for cybersecurity assurance and encryption algorithm and security chips. So in the system integration, you need to look at the onboard integration and cloud integration. This is a very hot topic. So cloud integration and also some other integration with the environment, like the V2X and so on. So how to develop the platform? So these are the challenging topics for the research, how to develop the basic database development platform for testing platform, and also how to look at the attack and defense platform. So the basic platform industry demonstration, architecture and ecosystem model. So the next generation technology exploration is about the cyber security considering multi-source information fusion. So these are some future challenge, future research from technology side. How to develop a cybersecurity software, a tool chain for centralized architectures, application value of AI encryption in automotive cybersecurity. So now you see that these are the very could be the next generation we have in the context of the technology development for automotive cybersecurity. Okay, so if we look at some R&D content, so basically we could say that automotive cybersecurity. So basically we need to look at the combination of the typical smart terminal characteristics about on the vehicle and also the traditional network security technology cybersecurity. So this combination of the vehicle and from some cybersecurity, so it should be integrated in terms of the automotive cybersecurity, the technology positioning, so about the planning and design, production, delivery for use and disposal, automotive cybersecurity life cycle integration, and also automotive cybersecurity protection strategy, including the domain isolation, defense in depth, and active defense. And these are the some basically protection strategy we have for automotive industry. So information security is a dependent and accompanying technology. So this technology exists first, and then there is a cyber security for this technology. So the process of the connected and intelligent vehicles come first. Okay, so for ICV, so when we have an ICV for intelligent connected vehicles, and then the automotive cybersecurity will be added to ICV. So now the technical system of automotive cybersecurity originates from the technical system of intelligent connected vehicles. So you see that here we have a scenario based information security. So about the intelligent connected vehicles face different cybersecurity threats in different application scenarios, and corresponding security defense strategies need to be implemented to achieve scenario-based cybersecurity defense. So cybersecurity and the functional safety. So in terms of the information security, addressing the malicious attacks, and by individual which directly impact the functional safety. So, and also the functional safety focusing on the random hardware failures so which do not directly affect the cybersecurity. So now you see that the safety critical system should be implemented. So the safety is related to the fault, as we discussed before, the failure. You see, but you know that the topic of the fault diagnosis and also the cybersecurity, so is appeared here. And it means that you need to have some safety critical system for the FDI, for the fault diagnosis isolation, for FTC. So that's it. FTC is also part of in enhancing the safety and security. But the cybersecurity critical system is related to information, because sometimes you have some malicious attacks, and these come from the data, and that's it. These two parts should be distinguished between the cybersecurity critical system and also the safety critical system. Okay, so in the context of the vehicle development process and throughout the entire life cycle of the car, there are some activities for the cybersecurity. So you see that the automotive electronic system cybersecurity, so it has a key part: integrated network security management, for example, network security culture, common communication platform training and the guidance. But for the cybersecurity management at each stage of the life cycle, it means that initiation of the network security assessment, the phase reviews. But without some conceptual phase for the system level automotive cybersecurity development process. So in fact, if you look at it from the customer level to the complete vehicle system level and component levels, so you see that these are some basically the conceptual phase. So from the hardware, software, to go to component specialization at the system level for the functional specification, and for the complete vehicle, and in terms of the function specification, technical specification, and coming to the customers. So now these are some phase we are dealing with the system level cybersecurity, because this can be applied at the system level. So we need to basically consider. So there are some issues about basically the strategic phase and also some security product planning. Maybe it's not it is a few detail, but let's talk to other parts. So one of the topics is the defense in the basic theory we have for the protection strategies. One is the defense in build. So it means that there is a high availability and a high vulnerability requirement. How to establish a comprehensive defense for in-vehicle external vehicle networks. So if you look at the in-vehicle protection, so it means that if you look at the node security protection, in-vehicle protection, security protection, and coming to the sort of the external vehicle interface security protection with the cloud. So now this is a very important topic, the cloud platform, communication platform. So as I told you that now in Italy, we work on the cloud basically the driver and also the vehicle. So what we are focusing, we focus on these 3 parts. So the protection, you see that can be defined for each part, for in-vehicle and other parts. Okay, so one thing is in the domain isolation. So we need to establish isolation for high asset data and software. So this means that at different levels, layers, user layer, process layer, virtual layer, and the hardware layers. So how to look at for example, about the application container, the trusted kernel. These are some typical security level we have for the domain isolation. in terms of the basically to establish the isolation for the high asset data and the software. So another interesting topic is active defense. So it means that the development requirement established for active defense system center on prediction. So now you can see that for the active defense, you need to work with the big data, AI, and also some other operation mechanism. So, but in fact, this active defense, based on some situation awareness and also some other emerging response. So you can develop some requirement for the proactive. So proactive defense is also very challenging topic for the connected cars. Okay, so now there are some basic issues about the defense in depth. So based on the characteristic of the in-vehicle application system and according to the different communication zones and distinct business and data flow features, a combination of the multi-level, multi-type strategies is adopted from the cybersecurity protection plan. You see that there are different levels from the sensor levels, the gateway, interface vehicle, and also the cloud servers. So at different levels, about for example, this data can be connected to the cloud with a smart charging. So then this is a multi-level defense in depth, how to secure authentication, privacy protection. So another level for the interface device, like a T-Box, V2X, or some other, the 5G, the Wi-Fi, Bluetooth. So you can see that there are some other issues about the secure communication, about the secure boot intrusion detection, in-vehicle network isolation, and firewall mechanism. So when you work on the sensor actuator levels, EMS, ESP, radar, camera, GPS, airbag, so for this part of the sensor and actuators, so you need to focus on the in-vehicle network monitoring, intrusion detection system, and encrypted transmission, secure hub, and the key security. So it means that these are some basics for the protection as a difference in depth. So for the domain isolation, it is another sort of the protection. So based on the value characteristics of automotive data and software securing the security isolation technology, so we have some sort of the, for example, virtualization technology, we have some sandbox technology. So of course, we need to have some trusted execution between the virtual technology and also the sandboxing. If we could develop this kind of technology based on the sandboxing, trusted execution, virtualization, and trusted routes, so we can use it to isolate a high value asset in the different domains. So now you see that here you have a machine, and in the machine you have the operating system, the Docker, and also some process container stuff. So then you have a sort of the virtualization technology based on the untrusted operating system, so the policy module, and so on. So now you have a two routes. You have a trusted routes, and also you have a trusted execution environment. So here, based on the local and the public the data they can be collected with the Wi-Fi. So it means that we can able to look at some things, some sort of the hardware platform security. So we see it composed of many items. But this brings that how we can isolate it. So this characteristic of the data from the hardware, the software, and also the security isolated technologies. So these are some issues we have in the redundant isolation. But in the active defense, so the main focus is from the vehicle side, the threats to the terminal threats, and also to look at some analysis using the machine learning. So the active protection for in-vehicle terminals, so usually there are three parts: for protection, response, and perception. In this case, so basically we can look at some perception as the core, data as a driver. And this was the reason that now we focus on the cloud driver and the vehicle, because so the perception is the main core in this part for the active defense of the cybersecurity. So then, therefore, there is a lot of research about the encryption, authentication, authorization. So security management, closed loop control, dynamic presentation. There are a lot of difficulties we have in the active defense. But if we look at a technical solution related to automotive cybersecurity deployment and also basic technologies, so we can see that we have some issues about the onboard networks, cloud, standing ecosystem, and communication process. So it means that ICV, IOV, V2X, and all they should be integrated. So now you see that there are many threats. So the threats analysis and the risk assessment, cyber security assurance system, encryption algorithm, the security chief. So it means that these are some issues we should consider. So in the industry status, so the cybersecurity risk assessment model is basis for effective risk assessment of activities. So the abroad mature risk assessment models exist for information security, but for example, in China, automotive information security risk assessment is nascent. So you need to look at basically this from industry. But for your information, because this topic is a very wide and very complex area, but just I give you some ideas that the general idea is to develop a risk assessment model for in-vehicle networks to analyze the threats, assess the risk, identify the assets and the threats, and establish the security requirement. So, and also the key task is task number one is the modeling and analysis of information security threats for intelligent vehicles, and also research on modeling the infosec risk assessment for connected vehicles. So this is the reason that now if you the threats analysis and risk assessment process for automotive network security, so it composed of many parts, including the threat analysis, risk assessment analysis. In the risk factor relationship, so you need to look at all the risks. The safe modes reduce the risk. So for